Hi friends, welcome all of you to the class of junctional epithelium. The last class was about the gingival epithelium. In that, I covered the cells of gingival epithelium and the keratinization process and everything. So today I will discuss about the junctional epithelium. This is an important topic. Junctional epithelium, actually, we know when we hear about junctional epithelium, everybody know that it is all about the attachment. So attachment of the tooth to gingiva. But actually this junctional epithelium is not only an attachment but also the host defense mechanism. It has lot of specialized features that is exclusively for junctional epithelium. And this also has a squamous non-keratinized epithelium. It is structurally and functionally very well adapted actually to control the constant bacterial ingress. So we will see how this junctional epithelium forms. Actually, this is the oral epithelium. This is the basal lamina. This is a reduced enamel epithelium. So this basal lamina that will contact with the epithelium through the hemidesmosomes. So that part I will discuss later. Once the initial stages of tooth eruption, this junctional epithelium presents at the enamel. During the eruption process, from the enamel, this migrate to CEJ, and once fully erupted, junctional epithelium can be seen at the cementum. So when this oral epithelium comes in contact with the reduced enamel epithelium, this junctional epithelium forms. Here the oral epithelium comes in contact with the reduced enamel epithelium. This junctional epithelium forms. So for mature junctional epithelium to form, it may take around 4 years. So now after the eruption, you can see this is the oral sulcular epithelium, or gingival sulcus develop actually once the tooth erupts into its position. So this can be seen between the oral epithelium and the junctional epithelium. Between the junctional epithelium and the oral epithelium, you can see the sulcular epithelium. So this is how the junctional epithelium is formed. If you see the picture, you will get an idea about this. Actually, this is a gingival sulcus. You know, this part is a gingival sulcus, enamel, cementum, connective tissue, pedial space, epithelial rust of molasses. Then this triangular part is the junctional epithelium, and it has actually this junctional epithelium is attached to two sides. So this side is attached to the connective tissue, and this side is attached to the tooth surface, and here it is attached to the sulcular epithelium. So it has three different parts. So the area which attaches to the connective tissue is known as the external basal lamina, and the part which is connecting to the tooth surface is known as the internal basal lamina. This is the cells inside the junctional epithelium, and the basal layer, the cells are little more cuboidal cells, actually basal and 1 to 2 supra basal layer, you can see the cuboidal cells, and when we go up you can see the flattened cells. So flattened cells, and there are a lot of specialities for the cells of the junctional epithelium. Actually, the cells which are attached to the tooth, no, this side the cells are known as DAT cells. It has lot of importance in host defense mechanism. This is all I will explain later, but now I am giving just an overall idea. And this junctional epithelium and sulcular epithelium and oral epithelium and epithelial rest of molasses, these all area together known as the dentogingival junction. So now I think now you get an overall idea of junctional epithelium. And then this junctional epithelium is single or multiple layers. It is non-keratinizing cells which attaches the tooth to gingiva, and this prevents infection by providing immunity. This length of junctional epithelium is about 0.25 to 1.35. We can say average 1.1 mm. Thickness of junctional epithelium is about 3 to 4 layers in the young individuals, but later this thickness can extend up to 20 layers. So the first, when we discussed about the anatomy of gingiva, we just mentioned about the biological width. Actually, this biological width is the junctional epithelium plus the connective tissue. That is the epithelial attachment plus the connective tissue attachment is the biological width. This junction, so I told now, no, junctional epithelium length is 1 mm, 1.9 mm, connective tissue connective tissue attachment is 1 mm, so overall 2 mm is the biological width. So this connective tissue attachment, or this is constant throughout the life. Even in the pocket case, this 1 mm is constant. So the biological width is 2 mm. Then I just mentioned, about the DAT cells. So this is external basal lamina, this is internal basal lamina. Internal basal lamina is not true because it is attached to the tooth surface. So external basal lamina is the true basal membrane. Its external basal lamina, they contain collagen type 4, 7 and proteins known as laminin and fibronectin. But in internal basal lamina, which contains collagen type 8 and protein laminin 5. So this I told, no, the DAT cells which are directly attached to the tooth. So this internal basal lamina, they produce specialized signaling molecule that signal the DAT cells to shedding and high mitotic activity. So this mitotic activity, so when the cells in the coronal surface, no, they are exposed to the gingival sulcus. Gingival sulcus is harbored by microorganisms. So these microorganisms, they attached and adhere to the DAT cells. So as a defense to this attachment, this DAT cells discommate and shed away. So that is why the process happening. So this mitotic activity that increase in the morning and decrease in the evening. So this mitotic activity increase in the non-keratinized epithelium, actually, because in non-keratinized epithelium there is no keratin, so no protection. So mitotic activity should increase so that more number of cells should be ready to fight against this microorganisms. So this is the function of DAT cells. So these DAT cells are said to migrate towards the bottom of the sulcus. So thus the epithelial attachment, we cannot say that is static. It is the epithelial attachment is dynamic. So what is epithelial attachment is the another name of the junctional epithelium. So this balance produced between the cell removal and formation. So this is known as the turnover rate. So this turnover rate is important so that the hemostasis of tissue can be maintained. So this junctional the turnover rate of junctional epithelium is actually 1 to 6 days. So it has the rapid turnover rate. So this protects the which helps the to increase the coming of attachment of the microorganisms. But the turnover rate of gingiva is 10 to 12 days, palate is 5 to 6 days, and outer epithelium is 2 to 2 weeks. So how then we will discuss about the stages of defense of junctional epithelial cells against the invading microorganisms. So now we discuss about the DAT cells. No, it discommates. So the discommation of cells is the first process of defense. Then we can see funneling. So how it happens? If cells of the junction epithelium get attached with the microorganism, these cells will funnel itself that between the interstitial spaces and then it reach the sulcus. So in that way we can protect the organism. So that is the another method. Then what this junctional epithelium will do is that the connective tissues there, no, they give some defense action. Then the other processes, they release some antimicrobial substance. So in that way also they can protect. Then another way is that they produce chemotaxis and PMNS. So they will the production will increase in that area. So in this further the PMNS will produce. So this further start a cascade of inflammatory and immune reactions. So reaction occur. So these all are the defense stages of defense of junctional epithelium. So when there is any disease activity, I told you this neutrophil, PMNS, this neutrophil come out of the junctional epithelium and they make a way in the junctional epithelium. So this neutrophil, they comes from the junctional epithelium and then they reach the gingival epithelium, and then from there it reaches the sulcus, and there we can see the gingival clavicular fluid. So when the neutrophil comes through, this neutrophil comes out, no, this process is known as diaperesis. So when neutrophil comes through the diaperesis, then bacterial antigens and there is a gradient is formed. And this neutrophil, which breaks the cellularity or connection with junctional epithelium, and they form a passage. And then along with neutrophil, extracellular fluid also coming out. This fluid is known as the gingival clavicular fluid. And I will talk about the gingival clavicular fluid in later episodes. And overall we will see what is the function of junctional epithelium. We told, no, this helps in the attachment to the tooth. But it is not only for attachment, it acts as a barrier and it has rapid turnover and antimicrobial defense and GCF flow. So these all are the function of junctional epithelium. So this is all about junctional epithelium. You need to understand the concept, that's it. So I finished with this topic. If you have any doubt, comment me, I will answer you. Thank you.